Now, with all proofs, we're going to work in that two-column format where we have statements and justifications. Before we begin, let's remember where we're starting and where we're trying to get to. So the congruent supplements theorem says I have angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary. And then what's my goal? Where do I know I've gotten to the end of my proof? What's the conclusion of the theorem as written? What? Are right. So that's where I'm trying to get to. So you want to kind of, whenever you do a proof, you want to be thinking, where am I starting? Where am I ending? And then what do I know that can try to bridge those gaps? How can I connect them? Now, another way to approach this, and staying with that metaphor, is if you don't know how to get to where you're going, just ask yourself, where can I go? Remember, going back to the analogy, if you looked at one of those cities, someone only had one flight out, so no matter what, you were taking that one. It might not have gotten you in the right direction, but at least it got you away from that statement. And that's something that you might want to use here. For example, if I say that two angles are supplementary, what do I know about them? Yeah, they add to 180 degrees. That's the definition of supplementary, isn't it? So I can say that the measure of angle 1 plus the measure of angle 2 is going to equal 180 degrees. Now these were my givens. Excuse me. What rule says that again? That 1 plus 2 equals 180? What rule takes two things are supplementary and ties them to adding to 180? The angle addition postulate says that two parts add up to the whole. Now, these aren't segments. Is this the definition of supplementary? If things are supplementary, then they add to 180? That would be, so I write definition of supplementary. Part of the challenge with this is not only are you working through the problem or trying to get from the given to the proof, you're also trying to recall all of these rules and justifications as to why you can do that. Does this also apply for angles 2 and 3? Yeah. So measure of angle 2 plus measure of angle 3 is going to equal 180 degrees. Same justification. Now I'm looking down here, and I want to get 1 and 3 on opposite sides of an equal sign. Can I do that with what I've got here? Can I take these two equations and somehow rewrite them so 1 and 3 are on opposite sides? What do you think, Melissa? So 1 plus 2 equals 2 plus 3. That works, doesn't it? Because they both equal 180. So I can set them equal to each other. Measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3. Now somebody else, what rule says I can do that? What rule that we've talked about says that if A equals B, B equals C, I can just write A equals C. Transitive. What's the other one I could call that? There's actually two possible answers. I'll give you a hint. I said this was 180, and this is 180, so I'm just going to plug it in. Substitution. Whenever you say transitive, you could also say substitution. Both work. Can I get the 1 and 3 by themselves? Is there anything I can do to get it down so it's just 1 over here and 3 over here, and these 2's are gone? Subtract what? All right, if I subtract, keep going. Subtract it from both sides. What rule are you using? So, it has a long name. What's the whole name? Subtraction. That's not going to happen. Subtraction property of equality. You're just like watching me sit up here go. I should stop doing that. It makes it a little too much fun. So measure of angle 1 is going to equal the measure of angle 3. And this, I'll tell you guys, is the definition of congruent. That's what I wanted to prove, right? I connected this idea to this idea. That's what I set out to prove, so I'm finished.